Data science terminology continued. Metrics, sparse metrics, classification and regression, pre-processing, observation, preprocessor filter, tokenization, DFM. We will scan through these topics and more. So let's begin with metrics. In a matrix, it's like a table. The rows are usually the observations that you have. So it's the data points that you collect your data. The rows are your data, usually, yeah? You can also transform the matrix, but in its raw form, then the rows are simply the observations. The columns are the features. You need to get used to it whenever you are using any data science algorithm implementation. Always remember, metrics, rows are observations, and columns are features. Get used to it. When you will add new features, you will add new columns. When you will add new data, you will add new rows. Each row is a data, each column is a feature. There are some cases where you need to transform it, but this is like the basics. This is ground zero of data science matrices. What is a sparse matrix? Well, especially in NLP, you have a matrix where most cells are zeros, or even most rows are zeros. The reason for that is that some of the features do not apply to all the data points. So if you have a matrix where most of it is full of cells of zeros, then it's called sparse because it's like it wide. And this is important because if you need to run some calculations on this matrix, then you're wasting a lot of CPU, you're wasting a lot of times. And it's important in data science because one of the things that takes the most times and one of the most obstacles in data science is that we are dealing with large data, and because we are dealing with large data, our computations takes too long, and sometimes you cannot even run the algorithms because they would take too long. So one of the things you do, you collide the sparse matrix into a shrinked mode where you get rid of all the zeros, and then your calculation will run faster. So a sparse matrix is simply a matrix where most of the cells or many of the cells are zeros. Classification and regression. In a classification, you take some input data and you simply have an output. Like, it's not necessarily a Boolean, it can be like a Boolean or multiple outputs. So it can be spam or not spam. It can be a color red, green, or white. It can be one of multiple outputs. So in classification, you predict the output, which is a class of something. In regression, when you take an output and you need to predict something, it's like, let's say, the Bitcoin price. So it's a continuous outcome. There are not distinct outcomes. So regression is more of a continuous outcome that you predict, and the classification is a categorical output that you predict. Preprocessing. Preprocessing is one of the most important phases in data science, where you take some raw input data and you clean it, you stem it. For example, in NLP, you do a data cleanup, you get rid of all the commas and the semicolons and stuff like this, and you want the raw words. Of course, they can help you, or these colons and other stuff, but there is enough information, at least for the algorithms of today, to deal with simply the simple words. So you take the data, you clean it, you do a stemming, and you do more operations, and you prepare a list of words for the algorithms to work on. So preprocessing is a phase that you will find in any algorithm where you take the input data and clean it and prepare it for the algorithm. The step one of your data science would be to observe the data. So in step one, even before the cleanup, we look at the data, you plot it. You take some of the data and you visualize it or you print a summary of it. Why is this step so important? It is important because you don't just take the data and run algorithms on it. You need to understand your data, because in many cases you cannot just run blindly the algorithm, and this is what differs a good data scientist from a not so good data scientist. A good data scientist will be able to observe the data and know which algorithm to apply, and not only that, he will know to do feature engineering, which is another term. Feature engineering would mean that you add new features to the data. Let's take the spam and not spam example. If you just let an algorithm run on the data, then it can run on the specific words and it will come with some prediction. But a good data scientist would observe the data and plot maybe the basic characteristics of the data, like its length and its size. And if you will look at spam emails, you might notice that spams are much longer than regular emails. Just think of yourself. When you send an email, it's not that long, but when you get spams, it's an automatic email. So the automatic mail that people send, they just throw away many words. They work on it for a few hours or maybe a few days, so they won't just write one sentence. It will be a bigger mail. So if you are a data scientist and you plot this data, you will notice that spam mails are much longer. And in this way, if you have a supervised machine learning algorithm, if you add a new feature of the text length, then you will have a much higher degree of prediction of whether the email is a spam or not. So this is an outcome of the first step of data science, which is to observe the data. And when you observe the data, you are able to come to such conclusions. And you come to such conclusions by plotting the data and examining and massaging the data. Then, only then comes the next step, which you have talked about, the pre-processing. But in this next step, after you observe the data, you start cleansing the data. You remove punctuations, you remove numbers, you remove stop words, you remove symbols, you do stemming to the data. And with this, you prepare the data for the next phases. The next phase would be step 3. So step 1 was to observe the data, have a look at the data, and for this you need to do some practice in order to get familiar and get the right tools for observing the data. Then you do some cleanup to the data, and then you do tokenization. Tokenization is simply the art of splitting the data into multiple tokens. And then when you have tokenize the data, you come to step 4. We are talking about specifically the steps for machine learning for NLP, but it's not necessarily for NLP, because observing and pre-processing for filtering and maybe even tokenization of data and DFM can be applied to other topics other than NLP. So in DFM is a short DFM term is a short name for document frequency matrix. It's a very high dimension matrix, and in this matrix you have, remember that we said in the matrix that the rows are the data and the columns are the features. So here the rows are the documents, so each document is a row and the terms are the columns, and for each such cell, which is a conjunction of a document or a row of data or a text message or mail and a word, you write how many times you saw these numbers appearing. So I saw the word A 4 times, I saw the word duck 4 times. It's simply a document frequency matrix, as its name is. It's a very good term, document frequency matrix. Each line is a document, an observation, and each column is a term or a feature, and you count the number of times you saw these terms in each cell. So this was our next terminology analysis for data science. If you like this video, please share, and I will share some resources I am using in the description right below. Thank you for listening, and see you next time.